Assalamu alaikum, it's me Husnain Sardar, your physics instructor for A-level physics 9702. So today we are going to discuss about alpha particle scattering experiment. Though you have learned a bit about of it in O levels, but here in A levels we are going to discuss in detail each and every part of the apparatus that we had used, and we will also conclude the results and will discuss about how this experiment was done and what were the conclusions about of it. Before starting that, I would like you to see this video where the whole experiment is described within a short way. Okay, so I will explain these things to you also. Okay, so let's start this video. Okay, so see in this video, as you can see that this one is basically a source of alpha particles, and you can see that here you can see that this symbol that is of radioactivity. Okay, so it means here we are having a source of alpha particles which is a radioactive particle. Okay, that are being emitted from this source, and we'll learn about of it as well, but here we are just discussing about of it in a very short way as a summary of it. Okay, so see see the alpha particles, they are being bombarded on a sheet which is basically gold foil. Okay, so on the gold foil they are hitting. Okay, and after that, see the gold foil, the setup is basically placed in an evacuated chamber. Okay, and it is hitting the gold foil. See, after hitting, see here you can see that the bright spots. So basically here is a screen which is made up of zinc sulfide. So this is called a fluorescent screen. We'll discuss about of it as well. See, wherever the particles are hitting on the screen, there will be the bright spots. Okay, so now here we have zoomed it to atomic level, and see alpha particles, they are going through the atoms of the gold. Okay, the center, that white dots, they are representing basically the nuclei of gold atoms. Okay, so as you can see that some particles, they are going through it without any deflection that you had learned in O levels, but here we will not say that they are going undeflected. We'll say here they are deflected at very small angle. I didn't say small angle, I said very small angle. They are being deflected because if a nucleus is having influence on the outermost electron a bit, definitely it can have influence on the alpha particles. So see, some of the particles, they are see here we have just used only one atom, one nucleus. Okay, so here the particles which are, see, the most above and most below alpha particles, they are deflected at a very small angle. Near to the center they are deflected at small angle, and which are hitting the nuclei, see, they are deflected, some of them are bouncing back. Okay, once again, I would like you to watch this video. Okay, so that before going to further. Okay, so we have discussed about the thing which we had already learned in O levels. Okay, so now we are going to discuss about the arrangement and all the parts of the apparatus that we had used here. So as you can see that here we are having a vacuum, evacuated vacuum. This basically this one is a lead chamber. Okay, so in it we are having a source of alpha particles, then we are having the gold foil. Okay, the detector of alpha particle, that is basically a traveling microscope. Okay, so which is used to observe the angles in which the alpha particles are deflected they're deflected after passing through from the gold foil. Okay, so one by one we are going to discuss about all the parts that we had used here in this experiment. So the first one that I've encircled, okay, this one, Okay, so that we are going to discuss about of it. Okay, so it's working fine. Okay, so the first one that we are having a lead block, which is used as a collimator. Okay, so it is used as a collimator. Okay, so what is the purpose of it? As a, we are going to discuss about of it. See, lead basically, this is a lead block that is used. Lead basically bete absorbs alpha particles. It also absorbs beta and gamma particles, but here we are discussing alpha only. So we are, I'm just writing here alpha particles. Here we put a source of alpha particles. Okay. See, if the alpha particles, see, alpha particles, as we know that radioactivity is basically a random process that which nucleus is going to decay, we don't know about of it. It's a random process. So the alpha particles, they will be emitted randomly. So wherever the alpha particles are emitting, the other ways will be absorbed by the lead. Only the one path, this one, they will not be absorbed by lead, so we will only use a part of it which is needed. Otherwise the other random parts, that will not be considered in the experiment. So that's why we have placed the source of alpha particles into lead block. Okay, so as you have already have done experiment in O levels when you used a ray box. So it is used as a ray box, okay? But instead of light, we are having the alpha particles. So while light is used here, okay, so lead absorbs all randomly emitted alpha particles and allow single path for their emergence towards the gold foil. So now we are going to discuss about that why gold foil is used. Okay, so here we have used the gold foil. So why only gold foil is used? We could use any other uh, sheet of paper. So why only gold is used here? Okay, gold foil. Okay, basically alpha particles, their penetrating ability is very less. Okay, even a sheet of paper can stop them. And about gold, the gold foil, the gold is having the characteristics of ductility and malleability. So gold can be converted into very thin sheets, very thin sheets. So the sheet is used so thin that even alpha particles can be used. Okay, this characteristic is not so much common in other metals, so that's why gold foil is basically used. Okay, so it is very thin foil and alpha particles are able to pass through it. Okay, now we are going to discuss about that why evacuated chamber is used. Okay, all these things are used for the specific reasons. Okay, so evacuated chamber. Okay. So why evacuated chamber is used? Okay. Okay. So basically, the ionizing ability of alpha is good. So it can ionize the gas near it or the air near it, and it could affect its energy, and we were wanting that all of its energy should be used for the experiment. So that's why evacuated chamber is used, where there will be a vacuum, so that alpha particles may not lose its energy in the ionizing of the air. Okay, so alpha particles may not, this is used, so alpha particles may not waste energy with air. Okay, so that's why evacuated chamber was used. So as we have already discussed about that white spot, the bright spots they were forming. So for that we had used the fluorescent screen. Okay, so the next thing is why fluorescent screen. Why fluorescent screen is used? Okay, so the gold foil. Okay, okay. The fluorescent screen, it provides position where alpha particles hit the screen as a white spot or as a spot of light is formed when alpha particle hits the screen. Okay, and one thing more, it is made up of zinc sulfide. Okay, barium platino cyanide, that can also be used, but usually zinc sulfide is used for this purpose. Okay, now see. Okay, now we are going to discuss about of that traveling microscope, which I told that it is used to measure the angles. Okay, so traveling microscope, it is very important part of this experiment, because it basically measures the angle in which the alpha particles are scattering after deflecting from the gold foil. Okay, it moves around the boundary of chamber, the evacuated chamber. Okay, to locate the position of a particle's hit, of a particle hit. okay, or all the particles they are hitting, okay. So these are basically the particles that are okay, these are basically the parts of this experiment that were used, and we have discussed about why they were used or they were so much important for these purpose, okay. Now we are going to see that what happens that we had seen in the video, watched in the video, that when the particles they are hitting, okay, and what happens to them after they are hitting the gold foil, okay. So as you can see that gold, okay, the rays they are hitting the alpha particles, oh sorry, gold foil, the alpha particles are hitting the gold foils, and we are having here three different kinds of behaviors. The first one is the type is A, okay. The majority of, okay, here we are going to discuss, now we are going to discuss about our observations, okay, what we observed, okay. So the first observation is the particles A, okay, which are falling in category A, okay. So in category A, what we are having, the particles, the majority of the alpha particles went straight through. The majority of the alpha particles went straight through. Okay. So what is it suggesting us that what happens here? So basically it is suggesting that atom is mainly empty space. This suggested the atom is mainly empty space. Okay. Now see about B. Okay. So as you can see that in B, some alpha particles deflected through small angles. Particles deflected through small angles. Oh, small angles. Small angles, like you can say that of less than 10 degree. So what is it suggesting us? This suggested, these are important points for CIA's MCQs. Like usually the last three MCQs, the last two MCQs in P1, they come from this topic. Okay, so it's very important. Okay, this suggested there is a positive nucleus at the center. Okay, because some definitely if they are being deflected, then definitely they are having the same charge as the particles are having, and the particles are alpha particles, they are having the positive charge. So definitely, but the thing which with which they are hitting, that is also having the same charge. And the type C, okay, only a small number of alpha particles deflected straight back at angles of greater than 90 degree. Okay, so what this is suggesting, like definitely they are being deflected, like they are bouncing back. So it means and there are very less particles which had got this behavior. Okay, so with which that like they are treated. So it is this suggested. ah, ah, you have to follow the pattern. Okay, this suggested the nucleus is extremely small. Oh, small. And this is where the mass and charge of the atom is. The mass and the charge of the atom, you can write like it will be a little bit clear. Okay, otherwise it's fine, but it will be better that if you write charge of the atom is concentrated. So it is showing that the nucleus is very small. It is having its mass is so much, and like all the mass of the atom is basically concentrated in the nucleus, and its volume is very less. So it means it's very dense particle. Okay, after completing it, we have discussed about the alpha particle scattering experiment. So we had discussed about all these parts. We basically produced alpha particles. After producing alpha particles, we try to, okay, I'll use the laser. Okay, okay, fine. Okay, so this is the alpha particles source. Here we have placed in lead okay, lead chamber. Okay, so after putting it in lead, we got a beam of alpha particles which is falling on this gold foil. After the going through the gold foil, the different alpha particles behave differently, so we observed them and got different results. See, A, B, and C. Were some particles went through straight with very small, I don't say small, very small angle, or you can say that undeflected. Some particles that, okay, majority particles that went through the straight with very small deflection or no deflection. Okay, some alpha particles that they deflected at very small angle, or small angle less than 10 degree, and only a few of the particles which were deflected at an angle more than 90 degree. So all of these deflections just helped us to understand the behavior of the shape of the nucleus. Okay, so we had discussed about the topic, and we also observed, okay, get a summary of it. So I'll give you some time to go through it and if ask if you find any difficulty in any topic. Okay, after asking the questions and solving them, I will definitely go through some questions which they had asked in the CIS. Okay, so in the CIS they have asked these questions. Okay, an alpha particle is close to gold, okay, gold nucleus, and is deflected through an angle greater than 90 degree. Okay, so it is for greater than 90 degree. Which property of the alpha particles? Here it is a misprinted. Here it is basically alpha particles. Okay, particles. Okay, particles. Alpha particles as a result of this deflection. Okay, so alpha particles that basically is going through gold nucleus and deflected through an angle greater than 90 degree. Okay, so but the particles which were well less. Okay, which property of the alpha particles as a result of the deflection? See, the charge, then definitely that will remain the same. Nucleon number, okay, that which is atomic mass also, that remains the same. Atomic number or proton number remains same. So here what thing is changed? That is the momentum, that will be changed. Okay, why? Because its velocity definitely, if it is bouncing back, then definitely its velocity will be changed. Okay, basically this is the homework that I will give you guys, but since it's a demo class, that's why I'm just solving these questions which will be solved in the next class to you in this class. Okay, so, in the alpha particle scattering experiment, a beam of alpha particles is aimed at a thin gold foil. Most of the alpha particles go straight through or are deflected by a small angle. A very small portion are deflected by more than 90 degree. The same that we had discussed already, effectively rebounding towards the source of the alpha particles. Okay, which conclusion about the structure of the atoms cannot drawn from the experiment? See, here the word cannot. Okay, so that we need to highlight here because it is the important point. Okay, so what we had observed in while discussing about the experiment, we got knew that alpha particles, most of the part of the atom is that was empty space. Okay, the nucleus is charged, that we had discussed that it was positive charge in the second point. Okay, then we discussed that most of the mass of the atom is concentrated in the nucleus, that we also had discussed this one. The nucleus contains both protons and neutrons. We didn't do any experiment which could show that this part was containing alpha proton and neutron. So this is the answer. Okay, the next, which statement about the alpha particle scattering experiment provides evidence for the existence of the nucleus? So now we have to discuss about which is the evidence of the existence of the nucleus. Okay, so I'm just taking the random uh, the option of it. The number of alpha particles deflected depend on the thickness of the foil. No, that wasn't depend on the thickness of the foil. The kinetic energies of the deflected alpha particles are unchanged. Okay, that's not the true, because in the starting the first MCQ we discussed about that the momentum was changed. Okay, in momentum we know that mass and velocity is involved. So okay, that is for the momentum, and in kinetic energy ek, we are that is equal to half mv squared. So since mass remains same and velocity is changed, so if momentum is changing, energy that will also be changed. Okay, slower alpha particles are deflected through larger angle. That's not true. The particles which were hitting the nucleus, that were deflected at longer angles, so larger angle. So a tiny portion of the alpha particles are deflected through a large angle. That's not true, because a very small number of the alpha particles that were deflected at large angles, which were hitting the nucleus. Okay, so when alpha particles are directed at a gold leaf, almost all the alpha particles pass through without deflection. So it is discussing about the size of the nucleus, size of nucleus, and a few particles are deviated through the large angles, that is representing the mass of the nucleus. So here, what are the reasons of this effect? So we have to see that where the size and the mass of the nucleus, that is discussed here. So most of the particles have energy, no, most of the particles miss the gold foil. No? Okay, so here we can see that the gold nucleus is very small, so that most of the particle miss all the nuclei. See, this is true. Okay, occasionally the path of an alpha particle is close to the nucleus. So It means that they are basically representing about the size and the mass of the nucleus. Okay. In an experiment on alpha particle scattering, particles are directed at thin gold foil. Most of the alpha particles pass straight through the foil or are deflected by a smaller angle. A small number of the particles are deflected at larger angles. They have explained everything about the experiment. Okay. So now they are asking which statement cannot be deduced from this experiment. So we know that three statements that we deduced from here. So we just need to see which statement was not cannot be deduced from here. Okay, atoms are mostly empty sphere. That's true. Okay, then most of the mass of the atom is concentrated in the nucleus. That's true. The nucleus of an atom contains protons. That we haven't discussed about of it, like which particle it is having. Though it is having a positive charge, but having a proton doesn't mean that it is having a positive charge. See, they're also having the neutron. So what does it mean that only protons are here? So that's not discussed in the experiment. So this is the option, or this statement cannot be deduced from the experiment. Okay, the nucleus of an atom is small compared to the size of an atom. That's true basically. Okay. Okay, last question of today's lesson. A beam of alpha particle is incident on a thin gold foil. One alpha particle collide head on with the gold nucleus and is deflected back along its original path. So it is deflected, basically it's bouncing back. Which statement could explain why the recoil speed of the gold nucleus is small compared to the recoil speed of the alpha particle? So why the speed of the recoil of the is less compared to the recoil of the alpha particles? So here we can see that most alpha particles are only slightly deflected, pass through the gold node. The alpha particles and gold nucleus repel each other. Okay, though they are repelling, but that's not the reason. Okay, the mass of the gold nucleus is much greater than the mass of alpha particle. That's the reason. And here one thing takes a role, or that is inertia. See, if this is the earth and this is an apple, the force which apple is applying, okay, the force with which apple is applying on the earth, the same force is being applied by earth on the apple. So why earth is not moving towards the apple and apple is moving towards earth? Because mass of the earth is more than the mass of apple. So that is the reason that the mass is more, so inertia will be more. So that is the reason betty apple falls towards the earth. Why? Because the mass of earth is more. So here the same thing is, the mass of the gold nucleus is more than the mass of the alpha particles. Okay, so that's the reason that option C is the right answer. So if you face any kind of the difficulty in this topic, you can discuss in the next class. Till the time, I hope that you will go through the other questions of it, which I'll give you the homework as well. See you in the next class. Allah Hafiz.